Let's reduce the number of features of this part without compromising model quality by taking advantage of Onshape's Mate Connectors for both design and built-in simulation. I was shared into this linkage model by a coworker, and he claims that he did this with the fewest amount of features possible. Well, I took that as a challenge, and you'll see how we can cut the number of features down for this design even further. Before I start my redesign, let's take a look at how this model was created originally. Upon review of his part studio, he started by sketching one half of the linkage. The sketch contains circles for the loop and tangent lines that create a 10mm connection point on the right plane. That sketch is then extruded at 10mm symmetrically along the front plane, so it has a square cross section. Now we have our first part. Then it's mirrored across the right plane to create a new part within Onshape's multi-part environment. They were kept as separate parts for now though, since the mirrored part is rotated 90 degrees along the YZ axis with the transform tool. Then they're Boolean together to get a single part in the part studio. As a finishing step, fillets were added to the square edges at the center of the design to create smooth transitions between both sides. Additionally, fillets were added to the outer edge of the linkage and chamfers to the insides of the loops. Now, could this be made much simpler? I'm going to try to figure this out within my own branch. By creating a branch from my colleague's original design, I now have my own environment to test out model changes that won't affect his design. No save as copy is required, it's still contained in my document, and no extra file is needed. What people may not know about Onshape is that you actually don't need a mirror feature to create this part, so I'm going to delete it within my branch. The rest of the feature tree fails, but that's okay. I open the next broken feature, the transform, and instead of just rotating the original part, I switch it to transform by mate connector. I need to select a from and to mate connector, so I select the middle mate connector on the square cross section that the design had been mirrored across before. This mate connector allows intelligence within the model to define not only the center point of the face, but also a coordinate system and a plane that can be used for transforming. Selecting copy part creates a new part within the part studio, but you don't see it appear yet. To this point, it's just a copy of the original part with the same orientation, but by flipping the Z-axis of the mate connector, we create a mirrored part, and then by rotating the axis of the mate connector, it does the 90-degree transformation step all within one feature. This solves the need for a mirror, but what about the broken features? Well, I can use Onshape's Edit Healthy Moment function to open the repair panel on the right side of the screen. The repair panel searches through the history of the document and finds the last time that the model didn't have errors. For each feature, cross-highlighting happens between the current model and the healthy moment. In this case, it shows the previously selected part from the mirror before, and once the Boolean becomes healthy, those fillets actually regenerate their references. The last step is to select a new face for the chamfer, and now we have what appears to be an exact replica of the part from my colleague's original design, but with one less feature. All that's left to do now is to use the compare tool to hold me honest to what I said, that the same quality of part would be created with less features. Within the compare tool, the left side of the list is my feature tree, and the one on the right side is the original design. As you can see, I've changed some of the parameters within the original features, but the mirror is actually only on the right side since I deleted it in my branch. Within the comparison, when I move the slider from right to left, it highlights geometric differences between both branches. You can see here that the entire design stays the same color, showing that I haven't made any physical changes to the design. I've proven here that it's geometrically the same, but let's do some simulation to further validate that I haven't compromised the integrity of the design. I'll start with the original mirrored part design. When my colleague defined this part, they used stainless steel. Since this material is already defined, all I need to do to prepare for simulating is to actually create a surface to fix my model to. Then I'll add both the part and the surface to my assembly tab. Onshape's assemblies only require you to define mate connectors between components, add a load to the part that you want to simulate, and make sure that there are materials for anything being simulated. In this case, the surface is going to be fixed, and I'll add a fasten mate between the linkage and my surface, since I don't need any motion associated. Next, I'll add a moment load to the other end of my linkage. Loads are added from the available options in your toolbar, and the direction of them is defined by the Z-axis of the mate connector that you select. Since I want to be rotating around the x-axis, I'm going to rotate my mate connector 90 degrees, so now it's facing the proper direction. I can check the connection to the simulation panel to help me understand the relationship between my parts, which in this case shows them as fastened together. If I had other parts I was testing or had different motion relationships between components, these would all be shown here. Just by defining the fixed surface and adding a load to the part that I added onto the design, my simulation is now fully defined. We are doing a comparison here, so I want to do this to the branch that I created on my own as well. Instead of setting this up again manually, I'm going to do it the quick way and merge those changes over to my branch to update the assembly tab. In the original design, since the other half of the linkage was defined with a different feature than how I defined it, I'll need to go and redefine the offset surface, and then within the assembly replace the surface and redefine the mates between the parts. That's quick work to do and keeps all the same simulation setup as the original workspace. Now that my two parts are set up and ready to simulate, I'm going to run them both at the same time. I can pull these out and have multiple tabs in split screen on my screen. Each tab acts like its own computational instance, so I don't need to be worried about multiple simulations running at once because all of them are done in the cloud and will get those results quickly without fear of crashing my machine. Now that we have our results for these designs, we can see that they're truly identical. Even though I used less features on my design, I made sure that engineering quality has not been compromised for this component. In fact, while I have these open, I can even change the material of my part to see if titanium would be stronger so I can make a better informed decision about material usage for the linkage. As soon as I open up the assembly again, it'll rerun with the new material parameters. Based on these results, they show negligible differences between the stresses, so we can start to consider other factors that we may want to optimize for this design, like cost and weight. All of this is possible because of the power of cloud computing, the flexibility of mate connectors within the modern-day CAD interface, and collaboration within Onshape.